Good day, everyone. I'm here to discuss the second classical method, which is the area moment method. So, what is area moment method? Area moment method is a graphical approach in solving beam deflections. This method is useful when you are determining the slope and deflection of a beam at a specific location. The two theorems in this method are the following. So, first theorem is the change in slope. So, the change in slope between 2 points is equal to the area of moment diagram of 2 points. The formula for this is this one. Theta AB is equals to 1 over EI times area of moment diagram AB. Next is the tangential deviation. Tangential deviation of a point on an elastic curve from the tangent drawn from the reference point is equal to the moment of the area of the moment diagram bounded by 2 points taken into consideration. So the formula for this one is TBA, or the tangential deviation of B with respect to the tangent drawn from A, equals 1 over EI times area of moment diagram AB times XB. XB is the moment arm, or the distance of the centroid to the reference line. So now, let's go to sign convention. So the sign convention for change in slope, or theta, is theta is positive if counterclockwise from left tangent to right tangent. So this one is the left tangent and this one's the right tangent. So papunta siya sa right tangent. So it is positive. Next is negative theta if clockwise from left tangent to right tangent. So for yung theta AB is going to right tangent. So that is negative. So for tangential deviation naman, positive if the point of elastic curve is above the reference tangent. So this one is tangent line. This one is the elastic curve. So nasa taas yung elastic curve ng tangent line. So that is positive. And negative naman if the point of elastic curve is below the reference tangent. O this one. Ito yung elastic curve, ito yung tangent line. So, nasa taas yung tangent line. So, it is TCA is equals to negative. So, that's all for the concepts. To further understand, let's go to sample problems. Now, using area moment method, calculate for the following. The vertical reaction at A, vertical reaction at C, moment at A, moment at B, and TBA. So let's go to the first step. So step 1, draw the moment diagram and modify. So imo-modify natin siya kasi non-prismatic yung beam. Meaning, hindi same yung properties ng entire span. For this specific problem, hindi yung span AB, EI lang siya. Tapos yung span BC, 1.5 EI. So, kailangan natin siyang i-modify. After natin kunin yung moment niya, i-modify natin siya. So, meaning M is M over EI yon. So, now, before we draw the moment diagram, let's identify first the reactions. So, here, sa point A, fixed support siya. So, we have VA and MA. At point C naman, we have VC and MC. So now let's get the moment diagram, but first we have to set up a reference point muna. So in this problem, ang gagamitin nating reference line is point B, or yung reference line B, kasi dito nagbago yung EI. It is advisable to make the abrupt change, yung point na abrupt change, as a reference line. So here, we're going to use point B as a reference line. Now, let's start. So, VA. So, ano yung moment ng VA papuntang point B? So, VA times yung distance niya, which is 7. So we have 7 VA. Next is yung MA naman. So, negative MA kasi yung sign convention natin. So, negative MA. Sa VC naman is VC times yung distance, which is 3 plus 2. So, 5. So, we have 5 VC. Pero, sa segment BC, hindi kailangan natin siya i-modify kasi hindi nga parehas yung EI sa entire span. So, in this segment, we have 1.5 EI. So, we have to divide the 5 VC sa EI kasi M over EI siya. So, we will have 10 over 3 VC. Okay, next. So, MC naman. Ano yung moment ng MC to reference line natin, which is point B. So, we have here negative MC. Negative siya. And then, i-modify din natin, we have to divide it sa 1.5, magiging negative 2 over 3 MC siya. Next is, yung rectangular load naman natin, this one, the 20 kilonewton per meter rectangular load. So, there. Nakuha natin to na 1/2, 20 times 5 equals 100. So, sa shear diagram pa lang yun, i-moment pa natin siya, di ba? So, 1/2 times 100 times yung length, which is 5, kaya nakuha natin yung 250. So, next, the 25 kilonewton per meter na moment. Magiging ganito naman siya, 25, tapos you have to modify it and you have to divide it by 1.5. Magiging 50 over 3. So, tapos na tayo gawin yung moment diagram. Next, we're going to step 2 na. So, sa step 2, draw the elastic curve and formulate the theorem equations. So, ito yung problem natin, and let's imagine the elastic curve in this problem. Fixed support siya, fixed support yun din yung point C. So, ang magiging possible elastic curve nito is, ito, diretso muna kasi fixed support, tapos bababa kasi yung mga load natin, tapos, pabalik dito. Ayan. So, magiging ganyan yung elastic curve natin kasi fixed support in both ends. So, from here, makakakuha tayo ng theorem equations. Makaka-formulate tayo from the diagram. So, malalaman natin dito na theta AC is equals to 0. And TCA, kapag nag-draw ka ng tangent line dito, sa TCA is equals to 0 then. So, we already have 2 equations. And we have 4 unknowns, the MC, VA, BC, and MC. So, meron na tayo dito. After natin isolve to, we can get the 2 equations sa equilibrium naman. So, let's start. So, this one. Theta AC, ito yung formula, equals 1 over EI times yung area moment lang. So, let's start. Sa MA, this one is a rectangular shape. So, negative MA times yung length, which is 7. So, we have negative 7 MA. Next is the VA naman. It's a triangle. So, 1/2 times 7 VA times yung length, which is 7. Next is the MC naman. It's rectangular. So, negative 2 over 3 MC times yung distance, which is 5. Next is this one, yung triangle din. So, 1/2 times 10 over 3 VC times 5, yung distance niya, kasi 3 plus 2, so 5. Next is this one, itong rectangle na to. So, 50 over 3 times 3, negative 50 over 3 times 3, kasi nasa baba siya. And lastly, this diagram. So, mukha siyang triangle. But the formula is almost the same. 1 over 1 plus n times base times height siya. So, this one is a 2-degree curve. Hindi siya diretso. 2-degree curve yan. 2 degrees curve. Ayan. So, now, yung n is yung 2, di ba? So, 1 over 1 plus n, so 1 over 1 plus 2 is 1/3. So, negative 1/3 times yung base, which is 5, yung length niya, and yung height, which is 250. Kaya, 250 times 5. Negative 1/3 times 250 times 5. So, let's simplify the equation. We will have negative 7ma minus 10 over 3 mc plus 24.5 va plus 25 over 3 vc equals 14 over 3. We already have our first equation. We can get our second equation sa TCA. So, let's go to next slide. So, this one. This one is the formula for tangential deviation. 1 over EI times area moment times moment arm, or the distance of the centroid to the reference line. So, in this case, our reference line would be point C. So, point C yung reference line natin dyan. So, let's start. Negative MA times yung distance, which is 7, times yung centroid niya. Ang centroid nito is nandito. Let's assume na nandito siya. So, negative MA times 7 times yung distance ng centroid to reference line, which is, ito is, di ba, ang centroid dito is L over 2. So, yung length is 7 and over 2 plus yung distance pa nito, which is 5. Next is this one, tong triangle naman. So, ang centroid nito is, let's assume na nandito siya. So, this is 1/3, diba? This is 1/3. So, 1/2 times 7 VA, yung height, times yung length, which is 7, times yung centroid nito, yung moment arm niya, yung centroid nito to the reference line, which is so 1/3 ng length, which is 7, plus yung 5. Ito, 5 to eh. Next is, itong MC naman. So, negative 2/3 MC times 5 times yung centroid niya, which is distance over 2. So, 5 over 2. Ito, length over 2. And then next is this one, ang triangle naman. So, ang centroid dito and nandito. Yan. So, 1/2 times 10 over 3 VC times yung distance, yung length, which is 5, times yung distance ng centroid to reference line, which is 2/3, kasi 2/3 to, di ba? 1/3 yung kabila, 2/3 to. 2/3. Yan. So, 2/3 times yung length, which is 5. So, next is this one. Itong diagram na to naman. So, let's assume na ang centroid nito ay nandito. Ayan. So, sabi ko nga kanina, yung formula for this ng area is 1 over 1 plus n times base times height. So, this one is 2 degrees, diba? So, 1 plus 1 over 1 plus 2, so 1/3. So, 1/3 times yung height, which is 250, times yung base, which is 5, times yung centroid nito. Yung moment arm nga nito. So, to get that, ang formula for that is 1 over 1, n plus 2. N plus 2 naman. So, add lang natin. So, 1 over 2. So, 2 pala, sorry. So, 1 over 2 plus 2. So, magiging 1/4 siya. So, 1/4 yung length naman nito. So, magiging 1/4 times 5 yun to get the centroid. Plus, eto pa. Kasi, di ba, sa C yung reference line natin. So, ulitin ko, negative 1/3 times 250 times 5. This one is the area, and this one is the moment arm. 1/4 times 5 plus 5. Okay? So, simplifying the equation, wait lang, sorry. May isa pa. This one, yung isang itong isang rectangle na to, we have 50 over 3 times, negative 50 over 3 times 3 times yung moment arm niya, which is 3 over 2 plus 2. Simplifying the equation, we will have this one. Negative 59.5 MA plus 539 over 3 VA, negative 25 over 3 MC plus 250 over 9 VC equals 16675 over 3. This is our second equation. And now let's go to the next. So our step 3 will be formulating the equilibrium equations. Kasi we already get the two equations from the two equations dun sa theorem equation. So now formulate naman tayo ng equilibrium equation. So this one, we'll have a moment and vertical summation of vertical forces. So here, magmo-moment tayo sa point B since yung sa dalawang equation na nakuha natin, MA, VA, VC, and MC lang nakalagay. So, para hindi naman madagdagan yung unknowns natin dito sa B na tayo mag-moment. So, summation moment B equals to 0, negative MA. Kasi, counterclockwise siya. Counterclockwise punta dun sa moment. Next is, yung VA naman. Clockwise siya. Clockwise, so, positive 7 times yung distance, which is 7. Next is yung MC naman. Clockwise. Papunta dun sa point B. So, positive MC. Next is VC naman. Counterclockwise, so negative siya. So, negative VC times yung distance, which is 5. And next is yung mga loads naman. So, we have here the rectangular load na pababa. So, magiging counterclockwise din siya. So, negative. Negative 20 times yung distance, which is 5, times yung centroid niya. Yung distance ng centroid niya to point B. So, 5 over 2. And then, lastly, the moment, which is 25. So, simplifying the equation, we will have negative MA plus 7VA plus MC minus 5VC equals 225. So, mas maganda na i-transpose nyo na kagad para mamaya input na lang tayo sa calculator. So, next, we will have summation forces Y or summation forces vertical equals to 0. We will have VA plus VA kasi pataas and VC pataas din siya. So, VA plus VC minus yung rectangular load na pababa, which is 20 times 5 equals 0. Simplifying this, we will have VA plus VC equals 100. So, we already have 4 equations. So, masasolve na natin yung mga unknowns. So now, let's solve simultaneously using 4 equations, 4 unknowns sa calculator. So next, input natin yung first equation. So, negative 7MA, negative 10 over 3MC, plus 24.5 VA, plus 25 over 3 VC, equals 14 over 3. Second equation, which is negative 59.5 MA equals negative 25 over 3 MC plus 539 over 3 VA plus 250 over 9 VC equals 16675 over 6. There. So, let's go to our third equation. So, yung negative MA, so negative 1, plus MC, so positive 1, plus 7 VA, so plus 7, minus 5 VC, so minus 5, negative 5, equals 225. Our last equation, fourth equation, so we don't have MA and MC, so 0 and 0.
Then VA, so plus 1. VC plus 1 equals 100. We will have MA is equals to 146.5918. MC is equals to 109.9767. VA is equals to 63.4679. And VC is equals to 36.5321. There.
So we're done getting the four unknowns, the MA, VA, VC, and MC. So now let's go to letter E, which is TBA, or the tangential deviation of B with respect to the tangent drawn from A. So now, solving for TBA, here's a problem. So in this problem, ito ang kailangan natin, itong part lang na to. So, let's start. So, TBA is equals to 1 over EI times yung, let's start with this one, the negative MA. So, negative MA times yung distance niya, which is 7. So, and yung centroid niya is L over 2, so 7 over 2. There. Next is the triangle. So, 1/2 times 7VA times yung distance, which is 7, times yung moment arm, which is yung centroid nito. So, 1/3 times 7. Next is this one. So, we will have this is a 2-degree curve again. I'm so sorry, I forgot to there. This is a 2-degree curve. So, negative 1 over 3 times yung height, which is 250, times yung distance, which is 5, and yung centroid niya, yung moment arm. So, 1/4 times 5. So, simplifying this equation, we need ito, MA and VA, kasi we have VA here, and MA. So, isa-substitute natin siya. So, negative 7 times 146.5918 times 7 over 2 plus 1/2 times 7 times 63.4679 times 7 times 1/3 times 7. And lastly, negative 1/3 times 250 times 5 times 1/4 times 5. So, we will have this one. TBA is equal to negative 484.0841 over EI. So, summarizing all the answers for this problem, we have MA is equals to 146.5918, MC is equals to 109.9767, VA is equals to 63.4679, VC is equals to 36.5321, and TBA, or tangential deviation of B with respect to the tangent drawn from A, we have negative 48.0841. So, to check this, kung tama yung sagot nyo using AMM, you can use other classical methods para ma-check kung tama yung sagot nyo. That's all. Thank you for listening, and I hope you learned something from my lecture video.